In this video, we will treat the gold foil experiment, which was done by the Rutherford. And this experiment results, the finding of this experiment resulted into changing the model of the atom in that is known as the Rutherford model of the atom. Okay, so Dalton was the first one to came up with the model of the atom, and he said that atoms are like small spheres that do not have any charge, and they are indivisible. So they are the same. You cannot divide it apart. So this was Dalton's model of the atom. But then later on, we saw it through the experiment that J.J. Thomson did, where he was discovering the charge to mass ratios, especially the cathode ray tube. Then what he did, he said that atoms actually are formed by mostly positively charged, and there are some negative charges that are embedded into that he called plasma, and this is known as the J.J. Thomson model of the atom. So through this experiment, cathode ray tube, and through Millikan's work, Millikan's experiment, was discovered what is the elementary charge. It is 1.60 times 10 to the power of negative 19 coulombs. And then the mass of the electron is 9.11 times 10 to the power of negative 31 kilograms. And mass of proton is 1.67 times 10 to the power of negative 27 kilograms. Later on, the presence of the neutron was discovered in the nucleus. And this was the start of that is known as the subatomic particles of physics. So now we have within an atom, and this is one of the important things or findings of J.J. Thomson cathode ray tube. So what he was doing, he discovered and he saw that within an atom, we have other particles like proton and electron. So atom is not indivisible, okay? So this is the main finding, or the main importance of J.J. Thomson model of the atom. Is the fact that we are now making the atom divisible. And then we come to the Rutherford. So the Rutherford was a graduated student of J.J. Thomson, and he was strongly influenced by the work of J.J. Thomson. There were a lot of experiments that were done by that time that were questioning the model of J.J. Thomson model of the atom. So then what the Rutherford did is his PhD thesis was to make an experiment so that it proves that the J.J. Thomson of the model of the atom is it. And as a result of this, he designed that is known as the gold foil experiment. We'll bring a picture of it here and then explain. So this is kind of a picture of the experiment that is known now as the gold foil experiment. In this experiment, the gold foil will use because it could be pounded down to a layer only a few atomic thick. So it's very malleable. And then alpha particle, or that are known as the helium ions, from a radioactive radium source were fired into the gold foil. And based on the experiment, and here was some zinc plate screen that the particles can hit. So based on J.J. Thomson of the model of the atom, what he was expecting was that alpha particles, since atoms are mostly negatively charged, will be deflected back. Okay? However, what he saw was that they were deflected all over the place. Some were deflected back, some were deflected back, like this one here. And some were even going through and deflected, some on the right and some on the left. When this was assembled, another scientist, Geiger, one of the Rutherford's graduate students, was asked to put the location on the collision with the zinc sulfide screen. Geiger later invented like something that is now known as the Geiger counter. So like an equipment that is used, and it is very used to measure even the radioactive elements of it, or measurements of the radioactive in air. So according to the J.J. Thomson model of the atom, we were not expecting deflection beyond, because since it is positively charged, an alpha particle is positively charged, then will repel it. But the situation was completely different. So it was kind of all over the place. However, based on this finding, what Rutherford proposed is something that is called the Rutherford model of the atom. And if we go back here, as a result of that, or let's go here. So the Rutherford model of the atom is important because what it did, it separated the positive charges from the negative charges. So it created that is known as the nucleus. So it said that atoms are formed by a mostly positively charged at the center. Okay, and then he said that the electrons are going around the nucleus in the same way as the planets are going around the sun. So now we have electrons going around like this. In some textbooks, this is known as the planetary model as well. Okay, so the importance of the model of the atom for the Rutherford is that he separated the nucleus, the positively charged nucleus, from the negative charges electrons. However, even this model had have some very serious flaws, and even you can figure out why there are some of the flaws. However, I will bring them here, and then you will see that what is happening. So first of all, did the electrons travel in the same orbit? If they did, why did they not bump into each other? So how was this structure of the orbiting electrons is designed. And then how the electrons are involved in bonding process with the other chemical compounds. Why the positive electrons stay together in the nucleus, and why they are not teared apart, why the nucleus, since it is positively charged, and why they are not teared apart. And the most important flaw is that Maxwell has shown that accelerated charges radiate EMR. This is the most important one. And then if the electrons are moving into a circle, which means that they're completing a uniform circular motion, why? And they have acceleration, which is centripetal acceleration, v squared over r. Since they are negatively charged electron and moving into a circle with acceleration, that how come that they are not radiating any EMR? We will talk about this later on. How come that they are not radiating any EMR? Because if they were radiating EMR, then they will continuously lose energy, and therefore they will collide and will come they will collide with the nucleus. So the path of the electrons will not be now a complete circle, continuously circle, but will be like a spiral. Okay, they will continuously lose energy, and they will either go away, or they will like this, or they will collide with the electron. They're releasing energy. Releasing energy, and then will collide and will come to nucleus. But we know that atom is one of the most stable one of the most stable structures of the matter. So there are things that are wrong with the Rutherford experiment, gold foil experiment, but there are important as well, because what it did, it brought the nucleus in one place. It separated the nucleus in one place at the center of the atom and made the electron away from the nucleus.